Hi everyone, welcome to Code Kamkaj YouTube channel. I hope everybody are doing good. In the last video, we have seen how to deploy a machine learning model through manual steps, and we have seen how to deploy it into a Kubernetes cluster. So there we have taken a Google Kubernetes engine. So in this today video, we are going to discuss about deploying the same machine learning model by applying CI/CD best practices of MLOps. So, in this video, whatever machine learning operations that we have done as a manually, like whatever machine learning methods that we have taken, and each method we have called and, via browser, and we have seen how to call it and how to test it via Postman and how to Dockerize it as an image. And after that, we deploy it as a container inside of the pod into a Kubernetes cluster. So we are going to make everything, whatever manual step we have done in the last video, as a automation by applying a CI/CD best practices. So now, if you heard about CI/CD, there are hundreds of tools are available in the market. Few are open source, few are enterprised. So it's up to you how flexible you are going with open source. And there were few tools are available for free trial, which even they are enterprise version. So it's up to your requirement, or up to your flexibility, which tool you're going to use for CI/CD as a continuous integration, continuous deployment, and delivery tool. So in this video, I'm going to take GitLab as a CI/CD tool, and whatever operations we have done via manual stages in the last video. So we are going to perform same stages into CI/CD pipeline by applying a DevOps best practices onto MLOps, which is machine learning we call it as. So we'll see what all stages we have and how we can integrate it, and what all things we need to, what all things we need to have along with the source code, and how we can make each stage. And we'll see what all the architectural diagram we can produce with a simple machine learning, CI/CD pipeline. So quick heads up, guys, before completing this video, I'm just going to give you notify that here we haven't integrated any complicated or any best practices of machine learning where you can use more dynamically for your productionization. Here we have in this video we have brought a simple machine learning model to be deployed by applying CI/CD best practices. There are a bunch of tools you can integrate it, like we have DVC and data version controlling, and we have the ML flow, and you can use a Qflow also, and you can use Airflow for all the operations like ETL, and we have a bunch of tools are available. You can integrate it to machine learning pipeline. But my agenda not make you more complicated. That's why I have brought very simple, like I haven't integrated any much more complicated tools into this machine learning journey. So first I will take a very simple machine learning automation. Later I will integrate whatever tools I have listed previously, like DVC and Airflow and ML flow, whatnot, into the upcoming session. And I'll make the videos of how we can make robust automation by applying all the available tools into this MLOps series. So stay tuned to this channel. If you haven't subscribed to this channel, I request you to subscribe it and share to your friends and family members who would like to learn CI/CD, DevOps, MLOps, and DevSecOps. So that's all for the introduction about it and what all we are going to do it. So as I mentioned, if you want to make a CI/CD, you should have a source code management, or you can call it as a code of truth. So for that, what I'm going to do, I'm going to take GitLab as a source code management. So you can use GitLab as a source code management, and you can use GitLab as a CI/CD tool, and you can use GitLab as an image registry. You can use GitLab as a model registry. So GitLab has a wide range of flexibilities there. We can use multiple ways as a GitLab. So here I'm going to keep my all source code. If you see, I think it's visible to you. So here I'm going to keep all my source code into my GitLab. So this is my GitLab. So I request you to ignore this noise, because I'm using some kind of different marker to write on my board, so it keep coming on while writing. So here I am here. So what I will do, I'll push all my source code, whatever source code that I have shown you in the last video, into my GitLab. So while I'm pushing, I'll create my repository as a public and private. It's a very basic things. And after pushing it, and I'll keep my source code where I have written a Flash application, and we have the directory structure. Along with the source code, what I will keep, I will two more files. One is a GitLab, one is a Docker file. To create a Docker image, we should have a Docker file. Another one is a Kubernetes manifest file. We call it as a K8 manifest file. In other hand, you can call it any name. So along with the source code, I'm going to keep my code plus Docker file and my Kubernetes file. So in short, you can call it as a K8 files. So in the Kubernetes files, we are going to have a deployment file, we are going to have a service file, and you can keep any one of the files into your source code management. And we'll get to know why we need to keep these Kubernetes files over here instead of cluster or instead of any server. So that in a manual step, we have seen like there itself, we have created a manifest file, like we have created a deployment file, we have created the service file. We have seen how to apply it, like kubectl apply -f, and we have seen it. So we have ran few issues also over there, like -f flag there. So we'll see like why we necessary to keep all your Kubernetes manifest file here. Along with this, we need to have a GitLab -ca.yaml. GitLab.yaml I call it as, because if you want to write or if you want to declare a CI/CD pipeline, so you should have to write code as a pipeline. We call it as a pipeline as a code, you can call it. So while writing a pipeline as a code, we call it as declarative. So we are going to declare everything in a YAML format, saying that what all stages we have, or what all global variables, local variables, how you can customize it. So you need to define, hey, to the GitLab, saying that, hey GitLab, I'm going to run a machine learning model, and how all the stages are available here. You need to run stage one by one, and you can customize it. If any stage fail, you won't let to go for another stage. So these all things we can look into the later. But yeah, if you want to create a CI/CD pipeline which is robust, so you need to declare everything in a structure. We call it as a pipeline as a code. So for pipeline as a code, you need to write GitLab -ca.yaml. So in the naming convention, you call it as a default naming convention. You need to specify it, otherwise your pipeline won't start. So here I have specified GitLab.yaml. So I have a very little space here. So yeah, while we're going into the implementation, we'll look into that how naming standards are more crucial. Fine. So we need to specify everything in a GitLab c.yaml files. First thing is a data collection, data pre-processing, EDA, feature engineering, and model training, model evaluations. For that, what I will do, I'll specify each stage by declaring into one stage and one job, and mention all the architectural diagram over here. So into my machine learning model lifecycle, so we have seen what is the first stage we called as a data collection, which is a data collection. So here we collect the data, and later we call it as a data pre-processing. Data pre-processing. And the next one is EDA, we call it as exploratory data analysis. And next we have the feature engineering. Feature engineering. And next we have the model training. And the next we have the model evaluation. And the next we can see that model prediction. I'm going to write it on here. And next we call it as a Docker build. And the next stage will be Docker push. And let me take over here itself. This is my Kubernetes cluster. KAS cluster. So this is a full amount of architectural diagram that I am going to walk you through in this video. So for this, it shouldn't be here. So this is the stages that we are going to integrate into our CI/CD pipeline, as along with its this one. So here we are going to install one Argo CD. Argo CD, and these can be namespaces, as up to you. Fine. So as we have seen, into the machine learning life cycle, first one is the data collection, data pre-processing, and EDA, feature engineering, model training, and model evaluation, model prediction. After that, we are going to create a Docker build and pushing into Docker image registry. It's called a Docker Hub. So we are going to declare each stage into a job or a stage into a GitLab YAML file. So we are going to write it down into YAML syntax. So first it is going to call the data collection.py, and later it's called a data preprocessing.py, and EDA and feature engineering. So whatever files that it is going to process, after pre-processing, so we have whatever null values we have dropped, we are going to save that Excel sheet or CSV file, you call it, as into the specific location. And after EDA and feature engineering, whatever feature we have selected, deselected, so we are going to reuse already saved CSV file from the location, and we utilize it. And later that, in a model training, so we have taken linear regression in the last session, and model evaluation, the test data and train data, and model prediction. So it will be model prediction also, it will be happen into my CI/CD pipeline. And later, once it is done, so I'm going to specify, hey, my Docker file is located into my source directory, which we call as a root directory. Take the Docker file and convert entire source code into a Docker image. So I'm going to do it here in Docker build, and after that I'll push the same image into image registry called as Docker Hub. Till this point, we have discussed into a manual deployment by last session. So we are going to automate the same thing into a CI/CD pipeline. We are integrating everything, data collection, pre-processing, EDA, everything to the till Docker push. So we are going to declare each job or each stage into a declarative pipeline. We call it as gitlab.c.yaml file, and we are going to specify GitLab. Hey GitLab, I'm not going to do anything. You have to do everything that I have specified into as a declarative way into my GitLab.c.yaml file. That's the beauty of CI/CD, guys. So we are going to declare everything, and later it will perform all the actions, and later it will push the image into our image registry. So how we are going to deploy it? That is where we have the Kubernetes cluster, and we have another tool called as Argo CD. So Argo CD is a tool it can be used for it came from GitHub, so it used for continuous delivery, deploying into a Kubernetes cluster, we call it as in the other hand. So what Argo CD will do, Argo CD will always watch your Docker image registry 24/7 and your source code. So where we have a source code, why we need to monitor source code? That's a question you might get it. So in a source code, it is not going to monitor entire source code. It is going to monitor a specific directory where you have a Kubernetes manifest file. We call it as a Kubernetes deployment file, a service file. So what Argo CD will do, whenever this entire pipeline has ran, so it will receive one Docker, latest image into image registry, and any commits are happened or whatever Kubernetes manifest file are reside in a specific directory. Argo CD will take those manifest file and those latest Docker image, and it will apply those Docker image mixing up into your manifest file, we call it as a deployment file, and it will deploy those it will apply those deployment into your Kubernetes cluster. So that is the beauty of your Argo CD. We will see, guys, in automation, how we can install Argo CD on top of Kubernetes cluster by step by step. So when it is deployed, so here I'm a user, consider I'm a user, and here he is going to send the age is 18, and salary is kind of 20,000. So what it will do, you send that data into this pod, which is running inside of my Kubernetes cluster. So the response will get back to this user whether the user is going to whether the user is going to purchase or not. So accordingly, you can guess, accordingly you can predict this via this model, whether as per the age and as per the salary, whether the customer will purchase the product or not. So that's the beauty of prediction by applying the regression model into the entire this CI/CD pipeline. So That's all for this lecture. I hope it is clear for everybody. Like, this is just architectural diagram, guys, and we have brought very simple machine learning architectural diagram. There is no any much complexity over here, and I haven't brought much complexity. And as I mentioned, MLOps is something that we are applying DevOps principle into the machine learning lifecycle. There is no any complicated things which we will be discussing into the future. There will be some kind of things which you need to have a basic understanding of DevOps. And as I mentioned, so here I have not integrated any open source tool which widely used in machine learning. If you go to LinkedIn, you will find, or if you go to Google it, you will find a bunch of machine learning tools will be available. My agenda is to just make you more understandable, very basic way, like just applying all the machine learning methods and all. And quick heads up, this is not productionized. This is very basic thing to make you understandable, knowledgeable on machine learning operations, how it look like, and how you can apply the CI/CD best practices. When it comes to productionization, entire architectural diagram will be changed. We are not going to perform everything as a CI/CD. We're not going to perform everything as a Flask application, what we have seen in the manual deployment. We'll cut a few methods. We'll be restrict those methods only applying on the server level, not exposing to the end user. If you see, like, in the last manual deployment, we expose the entire thing into the browser and we used to get the data on browser. We're not going to do that because it's not a best practices. But to make it understandable as easy, so I brought this sample architectural diagram, well, make it more understandable. So this is what, guys, what we are going to do by applying the CI/CD best practices on basic, simple machine learning model. And I hope it is clear for everybody. If you haven't understand it, so I request you to drop your comments in comment section of this video, and it will be clear for me to understand how good you're understanding. And if you have any questions or a specific point on why we need to use this, or why can't we use that, if you have any suggestions, drop your entire suggestion into your comment section. I'm happy to reply you back. So that's all for this, and thank you for watching, and subscribe to my channel, Code Kamgaji. And if you have any friends willing to learn MLOps or CI/CD or DevOps, DevSecOps, I request you to share this video. Until then, thank you for watching. Bye-bye.